Imagine a single chunk of rock, floating silently through space, holding more wealth than all the gold ever mined on Earth. Sounds like science fiction, right? What if I told you that very rock, and countless others like it, could kickstart a trillion-dollar industry and fundamentally change humanity's future? Welcome to the ultimate resource rush, not here on Earth, but billions of miles away, among the asteroids. So, what exactly is asteroid mining? At its core, it's the process of extracting valuable minerals and resources from asteroids and other near-Earth objects. We're talking about everything from water, crucial for rocket fuel and life support, to precious metals like platinum, palladium, rhodium, and even rare earth elements. These are the building blocks of our modern tech, and they're becoming increasingly scarce and expensive here on Earth. Asteroids, however, are essentially giant, pristine vaults of these materials. Why is this suddenly a hot topic? Well, there are a few compelling reasons. Firstly, resource depletion on Earth. Our appetite for raw materials, especially for electronics and green energy technologies, is insatiable. Secondly, the economics are staggering. A single metallic asteroid, just a few hundred meters across, could contain more platinum group metals than have ever been mined in human history, potentially worth trillions of dollars. Thirdly, and perhaps most excitingly, advancements in space technology are making the impossible seem, well, less impossible. Not all asteroids are created equal. We primarily categorize them into three types when it comes to mining potential: C-type, chondrite, asteroids. These are the most common, rich in water and organic compounds. Think of them as giant space ice cubes and carbon bombs. Water is absolutely critical. It can be split into hydrogen and oxygen for rocket fuel, allowing for cheaper, more sustainable space exploration and colonization. S-type, stony, asteroids. These are primarily silicates and iron nickel. They're less common but still hold valuable metals. M-type, metallic, asteroids. These are the real treasure chests. Composed almost entirely of nickel iron and precious metals like platinum, gold, and iridium. These are the trillion-dollar rocks we've been talking about. Imagine extracting just a fraction of the platinum from one of these. So, how do you even begin to mine a giant rock hurtling through space? It's not like sending a pickaxe and a hard hat up there. The methods being explored are truly innovative and heavily reliant on robotics and automation. Robotic explorers, first, probes would need to survey and identify promising asteroids, mapping their composition and orbital paths. Asteroid capture, rendezvous. Some concepts involve capturing smaller asteroids and bringing them into Earth orbit or lunar orbit for processing. Others focus on in-situ resource utilization, ISRU, meaning processing the materials right there in space. Extraction techniques. This could involve everything from drilling and robotic excavators to more exotic methods like solar concentrating mirrors to heat and vaporize volatile compounds, or even magnetic rakes for metallic asteroids. Space-based processing. Extracted materials would then be processed in zero-G factories, creating refined metals or propellants for further space missions. Believe it or not, several companies, both established aerospace giants and ambitious startups, are already investing heavily in this future. While some early pioneers like planetary resources and deep space industries faced significant hurdles and ultimately closed, their work laid critical groundwork. Today, companies like Asteroid are making headlines, planning to launch their first missions to test refining techniques in orbit. Trans-Astra is developing systems for asteroid capture and resource processing. Even national space agencies like NASA are keen on ISRU for future lunar and Mars missions, with asteroid mining being a logical extension. It's a testament to the belief that this isn't just a pipe dream anymore. It's not all starry-eyed optimism, though. The challenges are immense, to say the least. Immense capital investment. The initial cost of developing the technology, launching missions, and establishing infrastructure will be astronomical. This isn't a cheap undertaking. Technical hurdles: operating heavy machinery in zero gravity, dealing with extreme temperatures, radiation, and the vacuum of space. These are engineering nightmares that need solving. Logistics and distance: asteroids are far away. The travel time, communication delays, and the sheer effort of getting equipment there and back are significant. Legal and ethical questions: who owns the asteroids? What are the international laws governing resource extraction in space? These are complex geopolitical questions that need answers before the real rush begins. The Outer Space Treaty of 1967 provides a framework, but specific mining rights are still a gray area. So, back to our trillion-dollar question: is asteroid mining truly feasible? The answer is complex. While the technical hurdles are enormous, human ingenuity often finds a way. The economic incentive is undeniable. As terrestrial resources become more expensive and difficult to extract, the value proposition of space resources only grows. It's a long-term game, requiring decades of sustained effort and investment. We're not talking about profitability next year, but perhaps by the 2040s or 2050s, it could be a reality. If asteroid mining does become a reality, the implications for Earth and humanity would be profound. Economic revolution: imagine a glut of precious metals. This could crash commodity markets, but also create entirely new industries and cheaper access to materials for technology. Environmental relief: mining in space could reduce the devastating environmental impact of terrestrial mining, preserving our planet's delicate ecosystems. Space colonization: water and fuel derived from asteroids are the keys to sustained human presence beyond Earth. They would enable colonies on the Moon, Mars, and beyond, without having to launch everything from Earth. New geopolitics: the spacefaring nations would gain immense power and wealth, potentially leading to new forms of international cooperation or competition. Beyond the raw materials, asteroid mining is inextricably linked to the future of space exploration. If we can live off the land, in space, it transforms our capabilities. Imagine refueling missions to Mars with water-derived propellant mined from a nearby asteroid. Or building large space structures, habitats, and solar power arrays using metals processed in orbit. Asteroid resources won't just benefit Earth, they'll be the literal fuel and building blocks for humanity's expansion into the cosmos. So, when can we expect to see real asteroid mining operations? Most experts agree that the initial stages, prospecting, proof of concept missions, and small-scale resource utilization, could begin within the next 10-15 years. Commercial-scale operations, extracting significant quantities of valuable materials, are likely decades away, perhaps by mid-century. It's a long game, but the foundational work is happening right now. Asteroid mining is more than just a resource grab, it's a testament to humanity's ambition and ingenuity. It presents enormous challenges, but also promises unprecedented opportunities to transform our economy, protect our planet, and open the door to a truly multi-planetary future. The space resource rush is coming, and it has the potential to be truly trillion-dollar game-changer. What do you think? Is asteroid mining humanity's next great leap, or an impossible dream? Let me know in the comments below. If you found this video insightful, please give it a thumbs up, subscribe for more deep dives into the future, and hit that notification bell so you don't miss our next adventure into the unknown. Thanks for watching, and I'll see you in the next one.